All right, so I want to start by first explaining what slacks are. Slack variables are unused resources. They are the leftover resources when you have used the available resources. And therefore, slacks are defined as wastages. They are also called the right-hand side minus the left-hand side of the constraint. Normally, you want the resources to be fully used, but because of inefficiency, some people don't use all the resources. What is left is called slacks. Slacks can help you to write the linear programming in the standard form. Now, as you know, the linear programming is written normally with inequalities. But for some reasons, when you write the linear programming with equalities, it looks nice. And it can be used for other benefits, other purposes. Just to check with you what we have done already. We have looked at the Farm Ghana Limited, and we have indicated that the objective function is 40 fan yogo plus 50 fan choco. And we indicated that this is subject to 1 unit of fan yogo, 2 units of fan choco, less or equal to 40 hours of labor. And then 4 units of fan yogo and 3 units of fan choco, less or equal to 120 gallons of milk. You know this already. And that's your non-negativity constraint is this. You know this also already. We can convert this into the standard form. What you are seeing here right now is not a standard form, but we can convert this to the standard form. And the way to convert this to the standard form is by introducing 2 things. One, introducing equalities instead of inequalities. Write it down. You see, the best way to learn is writing everything I say. The second thing to do after introducing the inequalities is to introduce the slacks into both the objective coefficient, into both the objective function, as well as the constraint. How do you do that? Well, first of all, we are going to write the objective function again and introduce the slacks. As we know, the objective function is of a form like this. How do you determine how many number of slacks to have? Well, the first one is that count the number of constraints. In the example we have here, how many constraints are there? Forget about the non-negativity constraints. How many constraints are there? How many? You can type it. Those of you on the call, you can type. If you can't say it, you can type. You have 2 constraints. But ideally, even if I have not said you should type it, you should have typed it because this is interactive. So you have 2 constraints, and therefore you will need to have 2 slacks. The slacks are represented by S1 for the first constraint, S2 for the second constraint, S3 for the third constraint, and so on. If there are 17 constraints, there will be 17 slacks. But in the objective function, when you are writing the slacks, you attach 0 to the slacks. Why? Well, the reason why you attach 0 to the slacks is because the slacks contribute nothing to the objective function. Why? Well, take, for example, if you are supposed to go and work from 9 o'clock to 5 o'clock, 8 hours a day, And instead of working 8 hours a day, you got to the office at 1 o'clock. So you worked only for 4 hours a day. That means that you have wasted the other 4 hours. That 4 hours you wasted, it will not contribute anything to the profitability of the company. It's wasted, so it's gone. So the slacks contribute nothing to the objective function. That is why you can see that in the objective function I have here, the slacks are 0. Now, how do you introduce the slacks in the constraint? Remember, we said that the slacks introduction to the constraint will convert the inequalities to equalities. So how do you do that? You write x1, which is the same as 1x1, plus 2x2. Okay. Then you check the symbol. If the symbol is less than or equal to, you do minus S1. S1 because the first constraint will have S1 slacks. The second constraint will have S2 slack. The third constraint will have S3 slack. The fourth constraint will have S4 slack, and on and on. So you do minus S1 and do equal to the right-hand side of the constraint. So by introducing the slacks into the constraint, you have to make it equal to. But if it is less than or equal to, you make it minus. If it is greater than or equal to, you make it plus. That is how you introduce the slacks into the constraint. So for the second constraint, you are going to have 4x1 plus 3x2 minus S2 equal to 120. Now, regarding the last one, which is a non-negativity constraint, all you have to do is to write the same thing as x1, s2, then write also the slacks as s1 and then s2. And then you can now have greater or equal to 0. So what is the difference between the equation on the left and the equation on the right? The left one is this normal linear programming problem. But then the right one is the standard form. And you will always be told to convert the linear programming to the standard form. So you will notice that the right one, it has slacks introduced, and also the inequalities have been converted to equalities. The non-negativity constraint, that one should remain as inequality. This is how you convert the slacks. So if you want to know the slack value, all you got to do, as you can see, is to subtract the right-hand side from the left-hand side. And whatever is left will give you the slacks. That's all. Okay. And normally, whatever that is left is going to give you the slacks. So it is a matter of if this value of the S1 is minus, when you move it to the right-hand side, it's plus. And when you move it to the right-hand side, and then you bring this one to the left-hand side. If there is no slack, S1 is going to be 0 if there is no slack. Because if there is no slack, it means that all the available resources have been fully utilized, and therefore there is no slack. This is how you convert the linear programming from the non-standard form to the standard form. Now, the other thing you would also note is that if you have the opposite of the slacks is surpluses. So you may not have the slacks, but you may have the surpluses. That will lead to the same thing that we are discussing. So if you check your, and by the way, the slacks correspond to the lines of the linear programming. You know, when you draw the feasible solution area, it is the lines that create the area. So by using the slacks, it means you are working on the boundaries of the line and not in the spaces because of the equality sign. You're working on the boundaries of them. This is how the slacks work in the linear program. But let me ask you a question. Because if you understand the principle of the slacks, then you should be able to answer this. What do you think are the values of the slacks at the origin? What do you think are the values of the slacks at the origin? What are the values of the slacks at the origin? Okay. At the origin, you are not producing anything. And so the values of the slacks at the origin is not zero. At the origin, you are not producing anything. If you check the graph, you will always see it. This is here. You are not producing X1, you are not producing X2. And so it means that you are not using any of the resources that have been given to you. It is like you did not go to work at all. So you did not spend any hours in the work. Therefore, the slacks will be the total available hours. You wasted the whole day. So the slacks are equal to the maximum resources at the origin. Take note of that. If you understand slacks principle I've explained well, you should be able to answer that question, the value of the slacks at the origin. Okay, so that is it for the slacks. Now let's go to the essence of our presence for today. Today, we want to look at a practical example of a linear program that does not include two variable case, but it's more than two variables. It's more than X1, X2, but it includes X1, X2, X3, X4, X5. It can be as many as possible because life is not a straight line. How do you do such a situation? We are going to read a story, a case study. Then we will formulate the model in a linear programming parlance. Then we will also estimate the model in Excel. And then we will answer a series of questions based on the sensitivity report. That's the major work for today. That is the essence of our presence today. And I hope that you will not only look at the slides, but you will have your book with you. If you are sitting by your friend, tell your friend, take your book and a pen and write whatever that is going on. Write everything. Everything, write it. There is an information symmetry between your fingers and your brain. Your brain is an active populated environment. As you increase the lexical gymnastics, as you increase your cerebellum, your medulla oblongata, your oxytocin, the serotonin, and endorphin, as these things are increased, and they are increased by virtue of your writing. So as you are writing, you are elevating your mental gymnastics. And that is why it's always good to be writing, even if you don't understand. Because research shows that you will only remember 90% of what I'm saying. No, you will not. You will rather remember only 10% of what I'm saying. You will forget 90% of what I say. The only way you can remember them is go back to your book that you wrote, your notes that you made. That's how you learn. So let's take this case study, and then we'll formulate it, and then we'll solve it, and then we'll interpret it. You see that this is how your assignment is. Benyiwa though is an individual investor. I'm sure some of you know it. She has $70,000 to divide among several investment alternatives. Some of the alternatives she wants to invest in, the first one is known as a municipal bonds. There's an interest rate on that municipal bond, and the interest rate is 8.5% interest. She's investing in certificate of deposits. That one gives an interest of 5% return. She's gone into the treasury bills with a 6.5% return and a growth stock fund like the Data Bank M Fund. And this yields 13% rate interest. The investments are evaluated after 1 year. After 1 year, we'll come back and assess whether they were good investment or bad. But each investment has different perceived risks associated with it. So it is advisable to diversify the portfolio. And you can see that she didn't put all her eggs in one basket. In the process of portfolio diversification, she wants to know from you, a management scientist like you, she wants to know from you how much she's supposed to invest in each alternative instrument in order to maximize her return. Of course, she's not going to put this money to joke. She wants to maximize her return. How much is she going to get after 1 year? Now, the following guidelines have been established in order to help her to diversify her portfolio and cut down the risk. And you are to help to formulate this. No more than 20% of the total investment should be in the municipal bonds. That's the first rule. The first guideline, second guideline is that amount invested in certificate of deposit should not be more than the amount invested in the other three alternatives. Again, you are supposed to help her formulate this. At least 30% of the investment should be in treasury bills and certificate of deposit. To be safe, more should be invested in certificate of deposit and treasury bills than in municipal bonds and growth stock fund by a ratio of at least 1.2 to 1. And finally, Amma want to invest everything. Sell the $70,000. She wants to put everything into the 4 alternative investments. Question. My first question I want to ask you is that what is the objective of Amma here? What is her main objective? Who can tell me? All right, Anthony.
All right, sir. Please, Amma wants to know how much to invest in each of the alternatives in order to maximize the return.
So what's her goal?
To maximize returns.
That's all I needed you to say, but you had to read the whole thing for me. So she wants to maximize her return on the investment. You see, if you have done investment before, you know that this one, you don't even need to read it. Everybody that goes to doing multiple investment wants to maximize the investment returns. All right. Now, the first thing you need to do is to identify the decision variables. What is the exact decision variable that she has to deal with? Who can tell us? Who can tell us? From your head. Whether you type or you say, it's still from your head. What is a decision variables? And normally when you want to do the decision variables, you always start. Okay. This is your exam question, by the way. You want to start with let X1 be this, let X2 be that, and all of that. Okay. So the decision variable is something you have to identify in the question. So who can tell me what is X1? And for those of you who are typing, okay, remember that I will take exactly what you type. Alimatu says, let X1 be represent municipal bond. That's wrong. Alimatu says, X1 be municipal bond. That's wrong. Belinda says, let X1 be equal to represent municipal bond. That's also wrong. Gloria just wrote to municipal bond. That's also wrong. how you write matters a lot. You know, how you treat everything is how you treat anything is how you treat everything. If you rush in, you rush out. Harmony says number of municipal bonds to invest. That's also wrong. Now, Alimatu goes to check the answer probably somewhere. And now she comes to write this. Somebody is quoting something else for me. So, Michael, I like the answer you have given. Amount of money, how much should invest in municipal bonds? I was only asking you for X1. So the fact that you have written for all of them means that you are either picking it from somewhere. That's where I know. But I'm going back to Belinda. Is it Belinda? Alimatu. She has written a very sensible thing. She says that let X1 be the amount to invest in municipal bonds. That's the best answer. Okay. So X1 is the amount. If you don't bring the amount, forget about anything else. You say. The amount to invest in municipal bonds. Write it in full. Don't use shortcut. The amount of money to invest in municipal bonds. That is what Amma needs to know of. That is her decision. But if you just write the municipal bonds, you've said nothing, because municipal bonds could be the interest on municipal bonds, the investment in municipal bonds, the return on municipal bonds. It could be the interest rate on municipal, it could be anything. So saying municipal bonds is irrelevant. What is relevant is showing you understand. Of course, the others, X2 would be the amount to invest in municipal certificate of deposit, whereas X4 will be the amount to invest in growth stock fund. So that is how you define the decision. You check, this is 2 marks each, so that is 8 marks in all. So now that you've defined it, the next thing is to formulate the objective function. How do you do that? Well, we all know that to formulate objective function, it starts with Z max. So you start with your Z max. And then you will need to write your coefficient and multiply the coefficient by the X1. And now you know that the X1 is the amount to invest, the amount to invest. So how will you write the objective function? Who can walk us through? You take each coefficient. And by the way, which ones are the coefficients here? What are the coefficients? The story is basically in front of you. The coefficients are the interest rate. Now here he uses the word annual return, but it's not really the annual return. He's talking about annual rate of return. That's what he's actually talking about. So it is an interest rate. And so the first one for the municipal bonds is 0.08. So what you are going to write is 0.08 X1. That's for the municipal bonds. Then the certificate of deposit is all the 0.05 X2. That is for the certificate of deposit. Plus 0.065 X3. That is for the treasury bills. And finally, for the growth stock fund, it's 13%. So that is 0.13 X4. This is how you formulate the objective function. Once you formulate the objective function like this, you should know what each one means. So if I were to ask you that what I have circled here, let's say municipal bonds. I'm circling one of them here. So what I've circled here, what does it stand for? What I have circled, what does it mean? Who can tell me? Who can tell me the meaning of what I have circled? What does it stand for? What is that? What is that which I have circled? Raise your hand and tell me. Or type it there and let me know. All right, so I have answers like Harmony said, the total return from investing in municipal bonds. Alimati said a percentage to invest in municipal bond. Sadia, that is not the correct one. Bernard says return on municipal bonds. All right, so the answer by Harmony and Bernard is great. I like the Harmony one better because she brought the word total return from investing. Robert, that is wrong. It's not a percentage return. It's not a percentage return, but it's the actual return. It's money. It's a monetary return. So it's not percentage. It's a return. It's in dollars. It's not percentage. It's a return. It's in dollars. What is in front of it is a percentage. That's interest rate. The interest rate is a percentage. But the X is the amount you invested. So the amount you invest multiplied by the interest rate will give you the return. So note that. And then, of course, what you have on the right here is for the total return. Now that we have formulated this, we are ready to now go and look at the constraints. So we are going to check each constraint one by one. Let's go to the first constraint. The first constraint, it says that no more than 20% of the total investment should be in municipal bonds. Now, I want you to understand some key words in English. The word greater than can also be above. In case you don't know, that's it. The word greater than can also be above. The word less than can also be below. Now, let me ask you guys, what is the opposite of less than? What is the opposite of less than? You can type it or you can say it. What's the opposite of less than? Roberta says greater than. That is wrong. Jasmine said greater than. That is wrong. And I know all those who have greater than in mind will change it to greater or equal to. So the opposite of less than is greater or equal to. The opposite of greater than is less or equal to. And that greater than or equal to, and then less or equal to, these two, they can be represented by several words. For example, which word do you think is younger than? Younger than represent which of these symbols? Younger than. Younger than is less than. Very good, harmony. Okay. Now, which word do you think stands for at least? At least. It stands for which of these symbols? At least. Christine says greater or equal to. That's correct. It's greater or equal to. Okay. Now, which word stands for not below? Not below. Not below. What symbol is that? Not below. Anthony. And Michael says equal to. That's wrong. Anthony. Anthony says greater than or equal to. Yes. So first of all, you have to ask yourself, what is below? What is below? Below is less than. Okay, what is the opposite of that? The opposite of that is the not. Okay, the opposite of that is the not. And the opposite of less than is greater or equal to. So you should know these symbols because they keep coming a lot in linear programming. You see there's a lot also in queuing models and other things. Familiarize yourself with those grammar. All right. Now, with that in mind, let's go back here to look at this. It says no more than 20% of the investment. So with this, what symbol are we talking about here? What symbol is this? No more than 20% of the investment should be in municipal bond. You are learning how to formulate. What symbol are we looking for here? What symbol? Good. I like Jasmine. Instead of typing, she has actually written the symbol, which is better. So the symbol is less than or equal to. Okay, so we know that we are going to have less than or equal to in our first formulation. Now, 20% of the total investment should be in, so your mind should be English. You should ask yourself, what is 20% of the total investment? If you don't take it, you go and write things, symbols that are X and Y's and things like that you are not supposed to write. You may write 0.2X, which is wrong. Just go and calculate 20% of the total investment. The total investment is $70,000. Find 20% of that and tell us. Find 20% of that and tell us. What is 20% of $70,000? If you are here with us and you are not having your calculator, your phone, you are not having these things to be writing, but if anything at all, have your book with you and be writing along what we are doing. So that is 14,000. Now, this 14,000 should be on the right-hand side and not the left-hand side. Why? The reason is because you have been told that no more than, so already that is less than or equal to. And we know that the right-hand side is what has been available. You have been told that no more than 20% of the investment should be in municipal bonds. What letter? What letter number represents municipal bonds? Which X represents municipal bonds? That's X1. And therefore, X1, it should come in front of this. So you see that long bulleted sentence there is saying that X1 is less or equal to 14,000. It is a thinking formulation. You have been able to formulate that first header of constraint. So it means that, because we don't know that. So in other words, when we go into the final value and we get the X1 value, we expect the X1 value to never be more than 14,000. It can be 14,000 or less, but no more than that. Next one. The amount invested in certificate of deposit should not exceed the amount invested in the other three alternatives. What you should look for is the symbol. Which symbol is paramount in this sentence? Which symbol is paramount in this sentence? Harmony says less or equal to. That is correct. That is correct. Because the word exceed is greater than. So not exceed will be less or equal to. So we know that our next symbol is going to be less than or equal to. Okay. Now look at the sentence. The amount. So in this case, are we talking about letter or a number? The amount invested in certificate of deposit. The amount invested in certificate of deposit. The amount invested in certificate of deposit. What are we talking about? Are we talking about a letter or a number that we are calculating? Well, when you look at it carefully, okay, you will notice that because we are talking about amount invested in certificate of deposit, but we don't know the amount invested in certificate of deposit, we have already defined that to be X2. So it means that The amount invested in certificate deposit is X2. So what you should have on the left side is X2. Why should that be on the left side? Because we have been told that that should not exceed, which means that should be less than or equal to the total amount invested in the other three. What are the other three? They are X1 plus X2. Sorry, X2 has already been done. They are X1 plus X3 plus X4. So this is the way that you are expected to formulate this constraint. Because remember, we are dealing with the amount invested. And anytime you have the amount invested, that has to do with the decision variables. You see, that is why the way you write the decision variables matter a lot. So sometimes in formulation, you have to read the whole thing so that you look out for some of the keywords they are using before you start writing. This is how you write the two constraints. It's not clear. Let's go to the third one. The next constraint starts with at least 30% of the investment should be in treasury bills and certificate of deposit. I want you to think, and for the next 1 minute, tell me or write to me, either you type to me privately in the chat, or you raise your hand and walk me through perfectly how to formulate this very constraint. Who can tell us? Use 1 minute to think through. All right, so let me see. Only 3 people actually sent it to me. As somebody just wrote greater than or equal to 21%, X3 equals to 21,000. That's not correct. Someone said 21,000 less than or equal to X2 plus X3. That's not correct. We are writing mathematical formula. Someone says X2 plus X3 greater or equal to 21,000, which is the correct answer. And so the correct answer comes from Daniel Kujo. So this is how you write it. You have to first calculate 30% of the investment. 30% of the investment is 21,000. Then at least is greater than or equal to. We know that. So it says that at least 30% of the investment should be in municipal bonds, treasury bills and certificate of deposit. Treasury bills is X3, certificate of deposit is X2. So it's X2 plus X3 greater than or equal to 21,000. That is how you do it. That is how you formulate it. That's how. The next one. To be safe, more should be invested in certificate of deposit and treasury bills than in municipal bonds and gross stock fund. Now remember, by a ratio of at least 1.2 to 1. That word ratio means that whatever you have should have a ratio. So first, let's look for certificate of deposit and treasury bills. Now, certificate of deposit is X what? X2. So we are talking about X2 and treasury bills. Treasury bills is X3. Okay. And then it says it's a ratio, so that should be divided by something. And that something is municipal bonds and gross stock fund. Municipal bond is X1, gross stock fund is X4. Then it says that it should be at least is greater or equal to a ratio again of 1.2 to 1. 1.2 is a ratio to 1 is a ratio. This is it. That's how you do it. And now at this stage, you can cross multiply and move the items all to the left-hand side. When you cross multiply, you're going to have the 1 multiplying the X2 and X3. So you're going to have X2 plus X3. Then greater than or equal to 1.2 times 1, X1 is 1.2 X1. Then plus 1.2 X4. So at this stage, you can group lighters, move all of them to the left-hand side. And then when you do that, the 1.2 comes to the left-hand side, it becomes negative 1.2 X1. The X2 is already there, it's plus, so it's plus X2. X3 is already there, it's plus, so it's plus X3. Okay. Then 1.4 X4, when it's moved to the left-hand side, 1.2 X4 becomes negative 1.2 X4. Then greater than or equal to 0 because everything is left. That is how you formulate this one. It's the most difficult of the formulation. The last one is the AMA wants to invest everything. Everything is what? Everything is X1 plus X2 plus X3 plus S4. That's everything. If AMA wants to invest everything, that means you want all of this to be equal to 70,000. That's it. That's how you formulate that last one. That last one formulation is not difficult because you just want the amount you invest to be everything. So this is how you do your formulation. Don't forget your non-negativity constraint. The non-negativity constraint says that every decision variable should be positive. So X1, X2, X3, X4. All of them should be greater or equal to 0. That's it. Now, let me show you the final formulated model. You will see that it might look a little bit manya-manya, but hey, it is what you've just gone through. So this is a complete model that we just did. This model, you can rearrange and make sure that all the X1 comes first, X2 comes second, X3 comes third, S4 comes last. This is a model. I'm about to do this model in Excel. And then we will solve it using the Excel automatically. Now, what I'm about to do, I'm going to be so fast. I don't expect you to be able to follow me. If you have your laptop and you can follow me, but I will not wait for you. Like I said, I have all the way to go around it in the slides. So you can look into the slides and go through. So I'm going to fast formulate this. So just pay attention as you watch the skills in which I'm using. First, you must have your mathematical model in front of you. Second, you must open an empty Excel. You want to call the Excel AMA. And then we'll write the names of the decision variables. The first is the municipal bonds, then certificate of deposit, then treasury bills, and then gross stock fund. Below, we want to write the names of the coefficients. The first coefficient was 0.085 You can always toggle between the two and watch it. That is 0.085. That's the coefficient. Okay. The next coefficient is 0.05. This coefficient is 0.065. And the last coefficient was 0.13 or 13%. So these were the coefficients. Now, the decision variables, we don't know them, the amount invested. So we just want to call it DV. And for now, we will initialize their values to 0, just like I taught you in the previous one. Then you go to constraint. You type the word constraints. You want to put all the constraints down here. Now, the constraints, they are quite mixed. They are not just resource constraint, they are mixed constraint. So we want to give them the names like C1, C2. Okay, so the first constraint, let's call it C1. The second constraint, let's call it C2. And then the third constraint, on and on like that, we'll get to the fifth constraint. Now, let's go to the Z value, the objective function value. Let's call it Z. And let's put the value just below the Z on the same row as the coefficient. How do you find the Z? Well, as you can see in the model here, look at the model. You take each coefficient, you multiply each coefficient by the amount invested. Plus you take the next coefficient, you multiply the amount, blah, 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 by that. And there are two ways you can do it. You can use sum product to do that. Okay? You can do equal to sum product. Okay, to use that for it. So the first one, you can sum all of these. Okay, and bring a comma and multiply it by all of these. Then do F and F4 key. F and F4 key for the second one. You enter. Now the essence of this F and F4 key. By the way, you could have done this times this plus, this times this plus, this times this plus, this times this. You can do it. But then I'm trying this one for the first time. So now, the next thing you do here is to write under the row for the constraints. Okay. You write left hand side. Then you bring sign, and then you write the right hand side. That's it. As for the right hand side, you go and check. The left hand side, you go and check. But let's go here. Look at the first constraint. The first constraint, there is no x2, no x3, no x4. There's only x1. So under the x1 column, for that constraint 1, I'll just write the value of the x1. When you look at it, x1, what value is in front of it? What value is in front of x1 in the first constraint? So that is 1. So write that. Looks like some of you are sleeping. The next constraint is x1. You can see that there's -1 in front. So you write -1. And then x2, it is +2. So a +1 in front of it. So you write 1. Okay. And then x3, it's -1 in front of it. So you write -1. And then x4 is also -1. So the constraint 2 had all of them. Constraint 3 had only x2 and x3. And in front of each one is 1 and 1. So you go to the x2, you go to the x3, you type 1, 1. Constraint 4 had -1.2 in front of the x1. So when you go to the Excel, you will type -1.2. Okay. The x2 had 1, x3 had 1. So you type 1, 1, and then the x4 has -1.2 in front of it. You can always, you see, I'm toggling between the two. The last constraint, each one of them has 1, 1, 1, 1, 1, 1. So you go there and write 1, 1, 1, 1, 1, 1. That's how you do it. Now, let's go to the right-hand side. When you look at the right-hand side, the first constraint has 0. Okay, you type 0. The second has 21,000. So you type 21,000. The next has 0. Okay, so you type 0. The next also has, no, first had 14,000. You see, none of you was following, so none of you was even correcting. So first had 14,000. So let's write 14,000. Then the last one is 70,000. So you write 70,000. So this is how the constraints are. Now the sign is obvious. The first two had less than or equal to. You can see it in the model. Then the next two had greater than or equal to. Then the last one had equal to. So the first two had less than or equal to. Okay. And then I'll just toggle that down here. The next one has greater than or equal to. So I write my greater than, and then I toggle it down. The last one had equal to, but you can't write equal to. You have to bring the dot in front because Excel will see it as a formula. Now you are done. Copy this very one for the decision variable and paste it into the left-hand side for each one. So paste the first one and drag it to the others. Now, what that means is that each one will be picking the zeros. As you can see, when I double click, each one is picking the zeros. Formulation, done. Done. Formulation is done and dusted. Now we are going to solve. To do that, go to the top, click on Data tab. Oops. Click on the Data tab. On the far right, click Solver. Okay. So this is it. This is a solver. Solver requires that you post the objective function here. Now, if you look at our model, the objective function is the one under the Z. So inside the set objective, you put Z value there. It is a maximization, so select maximization. Then inside the by changing cells, you collect all the 4 decision variables into it. Okay, so you go and click the first one, which is 0, second one, which is 0, third one, which is 0. And then you put them there. Then you go to the subject to constraint area. Okay. Whatever is there, delete them. Okay. Whatever is there, delete them before you even start. It should be empty. And now let's add the first constraint. Click on add. Okay. And then come and select the first 2 constraints because they all have less than or equal to. So while the cursor is blinking on the left-hand side, which is called cell reference, click on these first 2. Okay. The less than or equal to sign is already there. Select it. And then click on the right-hand side and choose the 14 and the 0. You are done. You're about to go to the next one, so click Add. Once you click Add, click inside the cell reference again. Go and select the first 2 that have the greater than symbol and drag them. Click the arrow down and choose the greater than symbol, greater or equal to symbol. And on the right, click the 21,000 and the 0, which correspond to what you selected before. You are done. Go to the last one, click Add. And the last one is the 70,000. Its left-hand side is 0, so select 0. Click on the arrow, it is an equal to, so select equal to. On the right-hand side, it is 70,000, so select the 70,000. There is no more, so click OK. Let me tell you something, ladies and gentlemen. One of the things that challenge human mind is that some people, the moment they are learning something in life like this, then once they don't understand, they switch off. You don't have to switch off. You see, Life is always hard first, okay? Because this is the first time. It's like when you're learning to drive. You can't just come all of a sudden, sit in front of the steering wheel and boom, you just move. It is hard in the beginning, but you don't stop. You push through. When a child is learning to walk, the child will fall down many times. The child doesn't stop. She pushes through. My point is that when something is hard, the easiest thing for people to do is that they leave the Zoom, they stop, they start doing cha-cha-cha-cha. Then they break the very godly energy. But you have to remember that you have to go through your Red Sea in life before you can get to your promised land. That's what God did. He had to sacrifice painfully his only son. So you got to be willing to go through some not an easy life. And anytime something is a little bit difficult, push through. Tell yourself, I will until. I will until. And that is what I want you to do. If you go and watch this again, if you take notes and go and watch this again and watch it once and watch it twice, by third time, you are done. You can crack this thing and find it so easy. So your programming is what is hurting you. The last time I did a training on that, so many people have been programmed to think that anything that is hard should not be done. But it should be done. It should be done. The great people in the world have all done tough things. Elon Musk said he failed 188 times. You know, he has made the new robot that can talk, that can cook, that can speak, that can dance, that can serve you food. It can take your children to school. It has failed multiple times. Click OK. And be ready to soak life's pain, because that is how you grow in life. Nothing good comes cheap. Nothing good comes cheap. So you can go and do this thing at home, but listen, make notes, pay attention. Yes, Gloria.
Hello, sir. Thanks for taking us through. I just quickly wanted to find out if you could take us through why certain steps are being taken, because in our minds, I don't know if it's just me, but it's like we have to memorize the steps. But when we understand that there's a need for us to do a particular step, then that could help us not to just memorize the steps, but have a deeper understanding on why we are clicking a particular function and why something needs to be zero.
All right. So I have already done that in the first formulation of the Farm Milk Ghana Limited. Have you seen that video?
Yes, please.
I want you to go back there. You will see that I explain every bit of cells and what I click and why they are zero, why you write Z, why you write a sign, why you write everything. This is the second time I'm doing this. And I've also done a video, a different video on why each one is what it is. Okay. This video, I did it last year, and I've indicated that you guys should watch it. The last time I wrote it in the group page, that you guys should watch it. Okay. So first of all, I do not expect you to understand why all of these things are being clicked. But I also have explained why I'm clicking all of this in a different video. And so I do not want to be explaining it again now, because it will not help us to be able to get the interpretation of the result. In fact, for some classes I've done, I don't even go through this at all. I don't even do this Excel model. I tell them to go and watch the video. So by you, I want to do that. And I did mention I'm going to go through very fast, but there's a video that goes and explains everything. So go and to my channel, type Ama Benyiwa. You will see that I take my time and explain how these videos are. See, every lecture I take you guys through, I have 4 videos of the lectures. 4 videos. Some of them I did it when there was no student with me, and I took my time to explain in total everything. Okay? But if you are going through right now with me, you can't move faster with me. That's why you said I should explain. Okay. The reason why you are saying I should explain is because you are not able to move faster with me. But I've done a video where you can move faster. So you can move at the pace that because that one I'm slowing down and taking my time. So please go and watch those videos. And again, my interest is not your ability to do this formulation right now. No, right now, no. Right now, no. Remember, you cannot do it right now and understand it right now, no. But you can watch the video, not this video, that video. You can watch it, that takes you through it at your own pace and time, which explains all of this. Larry, I hope I've answered your question. Let me move on. Okay. So click make unconstrained variables non-negative. Okay. And you have to do that because of the non-negativity symbol that we had. Now, first of all, remember that this model we are doing right now is the most difficult. Okay. One of the hardest that you can ever do. Okay. So take the Farmer Ghana Limited one. That one is easier, and watch how it has been explained. And watch another one I did on agriculture. It's also in the videos there. Okay. Go to the playlist on management science. And I have several videos. For each playlist, there are multiple videos on the same topic that you should watch. In fact, I've even put the videos on the irregular types of linear programming there. And I want you to please watch those videos. Select simplest method, and that's it, and click solve. Once you click solve, you will have all of these things showing. You will now click on, where is that? You will now have the results here. Choose, select restore original values. And the reason why you have to do that is because you don't want the values here to show the results. You rather want the results to show in a sheet called sensitivity. So click on sensitivity and click OK. A new sheet will be created with all the sensitivity results, which we are interested in. I just did that. And here is a new sheet. And here is your beautiful result. Now, in an exam condition, I'll give a result like this, and I'll ask you 15 different questions. I'm about to address those same 15 different questions. This is where my interest is, rather. So this is where you have to be taking notes and then be writing the questions. And then whilst we address them, you address them. But remember, when I ask you questions, I will need you to answer me. Okay. So now, sometimes I'll break the questions down for you to be able to answer me. So we're ready. But this is and again, if you look at this, it's not different from what we did for the Farmer Ghana Limited. Okay, Farmer Ghana Limited, we also had variable cells here. Okay, and then we also had constraint. The only thing is that the decision variables are many here. So let's go to the first question. And you want to take note of the first question. The question says, oh, by the way, look at it. Everything that you are the modeling is in the document here. I have a copy pasted pictures, and then I am explaining with arrows, telling you what the formulas are meant for, what formulas are being used, and what they are being done for. Together with the videos, you should be able to define. Here, I explain what the decision variables are and all of that. Okay. Now, this is my first question. Write it down. You know, earlier on when we started the lecture, I said, write everything down, write it down. And I know that few will write it, but you should write it. Using the sensitivity report, what is the optimal solution to the investment problem? That's a question. What's the optimal solution to the investment problem? What is this question actually asking you? Using the sensitivity report, what is the optimal solution to the investment problem? This question was asked when we're doing the Farmer Ghana Limited. This same question was asked, but it was asked for using the sensitivity report. What is the optimal solution to Farmer Ghana Limited problem? But now we've changed the thing to, and there I explained, and we did a video, and I uploaded a video for you to watch before we come to this one. If you had watched it, this one will be fairly simple for you. So, what is this question asking you? Well, the optimal solution, and I did say it at that time, and I'm saying it again here. The optimal solution is always the final value of the variable cell. That's the optimal solution. It is always the final value of the variable cells. And this is what you should write down. I told you, you will forget 90% of what I say. Is the final value of the variable cell. So what would you say is the optimal solution to the investment problem? Okay, what are you going to advise Ama Benyiwa to do? You can tell me. Looking at the results. What are you going to advise her to do? What is the optimal solution? Yeah, Brandon.
Okay, so Ama Benyiwa should invest 38,181.82 in treasury bill, and also invest 31,818.18 in GS.
What is GS? You knew I'll ask you, right? You knew I'll ask you what is GS.
Growth stock.
No, it's not growth stock.
Fund. Growth stock fund.
It's a growth stock fund. Okay, so when you are interpreting some of these things, you have to go back to the storyline. Then you check the storyline. Okay, so that is it. That is the best answer you've given. And I like the fact that you didn't even talk about the municipal bonds and the certificates. I like that. You see, I just said the thing quickly. Municipal bonds and certificate deposit. But if you don't know and you're listening to me, you're supposed to write it down. So that when you are talking about it, you will not say MB or CD. Okay? Because even though I am saying MB or CD, I know exactly what they are meaning. So that is how I want you guys to really look at this. All right, so that is the first question. This is very interesting, by the way, because it means that Amma shouldn't even bother investing in MB and CD. Municipal bonds and certificate deposit are useless. That's interesting. All the 70,000 should go into the only last two stocks, the financial instruments. Practical. Very practical. Okay, next question. Next question says that, find the corresponding maximum investment return. Find the corresponding maximum investment return. How do you do that? You write a question down, by the way. Write it down. Before you said that you have forgotten the question and you don't remember the answer. Now, the maximum investment return can only be found by taking, that's why they use the word corresponding. Okay? Because initially you said that we should invest in this one. So this one that we are investing in, they have a corresponding interest rate, which is this 6.5% and the 13%. So the corresponding maximum investment return is calculated as, and I'm going to do equal to symbol here. It's calculated as taking each one of the final value and multiplying it by the coefficient, objective coefficient. So you take this final value, okay, you multiply it by the objective coefficient. You can even do sum product. Again, you see, sum product is a very easy way where you are producing some array and then summing them. So you are first taking the product. Product means multiplying. So you are multiplying the two numbers and then summing them. So I can take this one, this array, and that. Okay, it takes everything. It doesn't matter because they are all zeros here. And then you do a comma, and then you take this array and that, and then do Control F, and then just enter. No, it didn't work. It didn't work because I was just picking up. So let's do equal to. You take this one, you multiply it with a star by this one. Okay. Then plus, you take this one, you multiply it again by the 13%. This is how you find the maximum investment return. So if Amma were to invest that 70,000, the amount of return in dollars she's going to get is $6,618. That is a return she's going to get. So she will add this $6,618 to her $70, making her get $76,600. So at least she's made some very cool money in the first year. So this is the return, and you do that by multiplying each final value by its corresponding coefficient, plus another final value by its corresponding coefficient, plus another final value, and then on and on, so you add all of them. Next question. You would always get this question in an exam. Take it. Was the entire amount of money actually invested? That was a question. Was the entire amount of money, write it down in your book because we're coming to give the answer and then you have the answer in your book. Was the entire amount of money actually invested? Who can guess what the answer is? Well, looking at this data, something should give you a clue whether or not the entire amount of money was actually invested. How many? Tell us why. How many says yes? Tell us why.
So the 38,000 invested in the TB, the treasury bills, and then 32,000 invested in the growth stock bonds, it adds up to 70,000.
Perfect. Excellent. That is one way of finding the answer. So I'm putting the answer here. I'm highlighting it to be a bit like color, like blue here. So what she did is that she took this value here, 38,100 plus, and she took this other one that was put into the growth stock fund, added the two, and she got 70,000. And that is one way to detect that, yes, the entire amount was invested. That's another way. There's another way you can use to prove that the entire amount was fully invested. And that is at the bottom here. Okay. When you look at this bottom here, you will notice that, okay, and then you compare the last constraint. The right-hand side is equal to the left-hand side. Now, this last constraint, if you can remember in English, it was talking about Amma wanted to invest the entire amount. And so the entire amount was this, the right-hand side. And the left-hand side is what was invested. And you can see that the entire amount which is on the right is what was used on the left. The right is the available, the used, the left is the used. And since they are equal, it means that the entire amount was also used. So there are two ways to get the answers. That is it. And when you read this, I chose the last one, but of course, the first one is perfect answer. Okay. That the last constraint has the left-hand side equals to the right-hand side. Next question. What is the sensitivity range for amount of municipal bond? Explain it. What is the sensitivity range for the amount of municipal bonds? Explain it. So let's go to municipal bonds. Okay. Municipal bonds is the one that I am clicking. Let me click it and click it as green. So this municipal bond here, question is, what is the sensitivity range? Now, do you remember how to calculate the sensitivity range? Who can walk us through how to calculate the sensitivity range? Of course, the sensitivity range is written as the lower bound, then less than or equal to, okay, then the name of the sensitivity range, in this case, municipal bond, then less than or equal to again, okay, then the upper bound. That's how we used to do it. But what is the lower bound? The lower bound is always the objective coefficient. Objective coefficient plus, minus the allowable decrease. Okay. Then you have the less than or equal to the name of the sensitivity band, then the objective less than, then the objective coefficient again plus the allowable increase. This is how we used to calculate the sensitivity range. This is it. This is it. Now, how do you calculate that? Well, look at it. Take this value here. Okay. And then take the objective coefficient. Objective coefficient is 0.085%. I'm doing the lower bound. The lower bound, you have to do minus the allowable decrease. This is allowable decrease. That value here is infinity. 1e plus 30 is infinity. So when you do any number minus infinity, you are going to get minus infinity. You see that here. So that's it. That's a minus infinity. Now, the upper bound is the same value here. So let's do equal to, take the coefficient plus the allowable increase, which is this. When you add the two, you should get 13%. So the lower bound is negative infinity. The upper bound is 13%. You have to do all of this in your paper. But we will not take the negative infinity. Why? Because one of the rules of the linear programming is non-negativity constraint. Non-negativity. So anytime you get a negative value, take it as 0. So write 0 rather than that. And then the upper bound should be the usual positive value that you have. So we can say that, we can say that the lower bound is 0 and the upper bound is 13%. Finish. So anytime you get a negative value, make it positive. Sorry, make it 0. Only for sensitivity range. Only for sensitivity range. That is how. Now let's interpret this. What does this mean? This means that as long as the interest rate is dancing between 0 and 13%, the optimal values, all of these optimal values will not change. But anytime it goes below or above the sensitivity range, the optimal values of 38,000 and 31,000 will change. That is how you are interpreting it. This is a very, very powerful point. So this is how you calculate. You can do the rest. See, your friends, challenge your friend among yourself in your study groups and tell your friend, okay, you to calculate the sensitivity range for certificate of deposit. And I will do for growth stock fund, and he will do for treasury bills, and then compare your results. That is how you learn. Okay. Next one. Which diversification mix will yield the most return? Write it down. Which diversification mix will yield the most return? Which diversification mix will yield the best return? The diversification mixes are the constraints, okay, all of them. And you are being asked, which one will give you the most return? Who can tell me how to get the answer? Which one will give you the most return? How do you get the one that will give you the most return? For your information, the most return is the highest Z value, highest objective value. So which of these constraints or diversification mixes will give you the most return? Well, the one that will give you the most return is the one with the highest shadow price. So on the basis of that, who can tell me which one will give you the most return? Which one will give you the most return? All right. The one that will give you the most return is a constraint 5. The constraint 5 has the highest positive value of 0.04545545. And because it has a higher shadow price, it is the one that will give you the most return. The next question. The next question, which constraints are binding and why? Which constraints are binding and why? Well, the constraints that are binding are the constraints where the left-hand side is equal to the right-hand side. Okay. The constraint where the left-hand side is equal to the right-hand side. If we check this ones I've highlighted, okay, the constraints on the left-hand side are the same as the right-hand side. For example, constraint number 5, 70,000, 70,000 is the same. Constraint number 4 is also 0, 0. Okay. Both of them are 0. It is so clear. This value, as you see, is approximately 0 because you have e minus 12, the exponent. And so this last constraint, 4 and 5, they are the binding constraint. Every other one, the left-hand side is not the same as the right-hand side. And another way for you to know that a constraint is binding is when the shadow price is not 0. Whether it's positive or negative, the shadow price is not 0. And that shows that the constraint is binding. Next one. If Amma had a choice of investing in municipal bonds or certificate of deposit, which should she choose? There are 2 ways to answer this. Municipal bonds or certificate of deposit. By the way, constraint 1 is municipal bonds. Okay, constraint 1 is municipal bonds. Constraint 2 is certificate of deposit. So you can use this 2, or you can use their actual values here to check. The question is, which one should Amma invest in? Well, first of all, both of them have got a shadow price of 0. So Amma should not invest in anyone because the return on investment is useless. Second, both of them have got a reduced cost of negative. So even if you invest in them, the fact is that you're going to get a 0 return. Okay? You're going to get 0 return. It will cut down your returns. That's why it's negative. And so it's useless, once again, to invest in any one of them. But if it had happened that one of them had a positive shadow price, then that is the one you would have invested in. That's the one you would have. Remember, a positive shadow price is always best. A negative shadow price sometimes is even good, but it's not the best as well. But 0 is useless. Okay. Now, finally, nothing was invested in 2 of the assets in the optimal solution. And you can see that here, 0, 0 for municipal bonds and CDs. Nothing was invested. How much do you think the return for this would have to be for this product to be invested in? In other words, the reason why people didn't invest in them is because the interest rate on them are small. I'm not saying they are small compared to the others. They are just small. They are just small. Look at the interest rate. The coefficient tells you that one is 8.5, the other is 5%. That is why they are zero. That is why you didn't invest in them. Investment is zero. Now, what should be done to motivate AMA now to invest in them? That's what the question is saying. How much would the return for this product have to be for it to be invested in? How much should it be? Well, it should be up to the upper bound of the sensitivity range. Write it down. Okay. For any product whose final value is zero to be invested in or to be produced, its coefficient should be increased up to the upper bound of the sensitivity range. And in this case, you just have to take the 8.5 here, add the 4.5 to it, the allowable increase, and that will be 13% for the municipal bonds. For the certificate of deposit, take the 5% here, add the 1.5 to it, that will be 6.5%. That will be the upper bound of the sensitivity range for CD. So in both cases, well, as long as the interest rate is increased up to the upper bound of the sensitivity range, it makes sense now to invest in them. It makes sense to invest in them. That is how you think through this investment strategy. So you see, so when there's a lot of investment strategy, this is one way you can use to tell which one to invest in, how to diversify portfolio. That's why I'm saying that it's easy to be wealthy if you want to be wealthy. It's actually hard to be broke. It's hard to be broke than to be wealthy if you have the knowledge. Hosea 5:4-6, lack of knowledge. All right, so all of this have been calculated here for you. Go through it yourself and appreciate it. Ladies and gentlemen, that brings us to the end of the entire caboodle. Linear programming is a very powerful way for you to solve problems in real-life market systems. If you take your time and analyze and learn how to formulate the model, you will get a solution. When the model is properly formulated, there is a solution. When the model is not properly formulated, there is no solution. So please watch some of the videos. Ask questions in the group page. That is where I see the challenge. The challenge is that right after Saturday, you guys are gone. You go, you put your book right under your table. Gone, bye-bye. Maybe. Okay, then it piles up. It piles up, and then we come back to another week, and then it starts building up again. You don't want to do that. I've also indicated that if you are drowning, if you have any challenge, okay, you can backstage me. If you need someone to guide you separately, you can backstage me as well. Okay? But you have to remember that ultimately it depends on you. You are the alpha, you are the omega.